In today's tutorial we will have a look at the formation of peroxides, or more precisely hydroperoxides, in ether solvents. So typical ether solvents which are often in use in the chemical labs are MTBE, methyl tertiary butyl ether, then THF, tetrahydrofuran, diethyl ether, and diisopropyl ether. Very often THF and those other two ethers are contaminated with peroxides, hydroperoxides. MTBE is not contaminated with peroxides. Here, those peroxides will easily form. In this case, not. This has a reason. Well, it's just because we have, for the formation of peroxides and hydroperoxides, radical intermediates. Well, and a radical is most easily formed at these isopropyl groups. Imagine having a radical center here. This is a stabilized tertiary radical. Here, a radical center is a stabilized, mesomerically stabilized secondary radical. Those are stabilized. This is not possible with MTBE. So, the diisopropyl ether is able to react directly with oxygen in the ground state. This is triplet oxygen. This reacts even in the dark. For the reaction with oxygen, THF and diethyl ether need light, so photochemical irradiation to start the reaction. In that case, triplet oxygen is transformed by photochemical irradiation to singlet oxygen, and this is far more reactive on a higher energy level and is able to abstract a radical hydrogen from diethyl ether, forming this stabilized secondary radical and the hydroperoxide radical. This hydroperoxide radical can then react again with the second equivalent of diethyl ether, forming hydrogen peroxide, and this radical here again. Well, a recombination might take place between this radical and that radical, forming already diethyl ether hydroperoxide. This molecule we will call the molecule A, but it can also initiate already a radical chain process. So we have this radical, and that can react with oxygen already in the ground state, the triplet oxygen, forming this peroxy radical. That can now again react with diethyl ether, forming this type of radical again, which we already had here and here, and the diethyl ether hydroperoxide would be the result. So, just getting a radical hydrogen to this position will form that one. So, this molecule in bulk is a liquid, but a highly explosive liquid. It can transform by condensation processes. Well, how do those work? This is some kind of an acetal functionality, and a trans-acetalization can take place For instance, two molecules of that, 2 times A, can condensate by forming ethanol, and this molecule with already 2 peroxo units, and in the following it can form such polymers which then are colorless solids which could remain after evaporating contaminated diethyl ether. And also this solid is highly explosive. You don't want to have that in there. It's dangerous. How can you get rid of those peroxides? First, testing, are they in there with some test kits which are everywhere available for in your lab, I assume. But the easiest way to get them rid of that, I think, is just an adsorptive filtration through aluminum oxide basic super 1. So how do you perform that? Well, just take a normal column for column chromatography. Fill in this type of active aluminum oxide and then filter the ether solvent just through that aluminum oxide. The peroxides, as far more polar, will remain here in the first few centimeters. Don't forget to test for peroxides after you have filtered it through it. And there is one additional thing you should keep in mind. As soon as the aluminum oxide gets into contact with the ether, it will develop some heat. And there you must be careful. First, slowly letting it pass through the aluminum oxide, because, as you know, diethyl ether has a rather low boiling point. So, and the first fraction, which is somewhat warm, you should put again on top, and to go sure that it is really freed from the peroxides and also freed from water. Aluminum oxide basic super 1 is simultaneously used for drying or pre-drying that solvent. Later on, you can add some pressure that it flows through it a bit faster. Thanks for listening.